Hello students, welcome to Physics Pathshala. Today we'll study on projectile motion. As the name says, projectile motion is motion of a projectile. What is a projectile? Projectile is an object. If it is thrown from the time it left the ground and till it touches the ground, it remain in air. It is said that it is in flight. It is in flight. Then this object is termed as projectile. That means any object when it is thrown or projected, an object when it is thrown or projected, it remains in flight. Then this object is termed as projectile. That is, projectile is an object that is in flight or air after being thrown or projected. This object is termed as projectile from the time it has left the ground till it touches the ground. Motion of this projectile is termed as projectile motion. It will have motion along two directions simultaneously. That is, along the ground, or we say horizontal motion, and another one is perpendicular to ground, that is vertical motion. That means projectile motion will have two motions simultaneously. That means at the same time it will have horizontal motion and it will have vertical motion. Horizontal motion is along the ground. Another one is vertical motion or perpendicular to ground. That means it is moving in a plane. Plane is something have certain area and required two coordinate system, two coordinates to express location or position of each points. In plane. That means any point in a plane required two coordinates to express its position. We say here x and y are the coordinates, and the system is termed as two coordinate system. That is, we will have x-axis and y-axis. Both are mutually perpendicular to each other. One is a x-axis, another is y-axis, and both axes are mutually perpendicular to each other. This x axis, this y axis, both are perpendicular to each other. This type of coordinate system is termed as two coordinate system, two-dimensional motion. This motion then termed as two-dimensional motion. Here we will have horizontal motion and vertical motion simultaneously. That means at same time, it will have horizontal motion and vertical motion. Horizontal motion is the motion along the ground, and vertical motion is the motion perpendicular to ground. Vertical motion is parallel to ground. When the object moves parallel to ground, there is no acceleration. We say acceleration is equal to 0, or velocity is not changing, that is remaining constant. Whereas in vertical motion, velocity changes and acceleration is not 0, acceleration is g, that is acceleration due to gravity, and velocity changes. When the object moves from ground towards upward, velocity decreases and g is negative. When object moves from height towards to ground, g is positive. That means vertical motion will have two motion. One is upward motion and another one is downward motion. During upward motion, that is when object moves from ground towards upward, velocity decreases and g becomes negative. When object has downward motion, that is from height it comes towards ground, this is our downward motion, and when object moves from ground towards certain height, it is upward motion. During upward motion, velocity decreases and acceleration is minus g. Whereas during downward motion, velocity increases, this acceleration is plus g. This is the fundamental we have to remember during upward motion and downward motion. Now, during horizontal motion, acceleration is 0 and velocity remains constant. As we have studied in earlier class, kinetic equations are, one is V is equal to U plus AT, where U is the initial velocity of an object. If it moves with certain acceleration, after a certain time it will attain its final velocity. And after a certain time it will move certain distance, S will be ut plus half at square. These two equations already studied in previous class. Using these two equations, Now we can find out the distance it has moved and the velocity after certain time t. Let's, if an object is thrown, it becomes a projectile and its motion becomes projectile motion. At t is equal to 0, let it is at the origin. Origin is x equal to 0, y is equal to 0. You can write 0 and 0. It is thrown with an velocity v0. v0 is the initial velocity with which the object is thrown. Now, this v0 will have its component along x-axis and y-axis. And this v0 is thrown at an angle theta to x-axis. Now the component of this velocity along x-axis is v0x and component of this v0 along y-axis will be v0y. This v0x will be having the value v0 cos theta and v0y will have its component v0 sin theta. This is the initial velocity along x-axis and this is the initial velocity along y-axis. As time passes, late after certain time, object has reached at some point, then it will have its new velocity along x-axis and new velocity along y-axis. And during this time it has moved certain distance x along x-axis and certain distance y along y-axis. Then we can say x is the distance it has moved along x-axis using the formula s is equal to ut plus half a t square, where u is the initial velocity, t is the time and a is the acceleration. Here u is the v0x and t plus half a t square, a is 0 because acceleration is 0 along x-axis. Now x becomes v0xt, which is equal to v0 cos theta into t is the distance it has moved along x-axis. In same way, the distance is the object has moved along y-axis is v0y t plus half a t square, where a is minus g for upward motion till it attains the maximum height. It is in upward motion and from there it will have downward motion. Now this y becomes p0 sine theta t minus half g t square. At the same time, the velocity, let after time t, the object has reached at point A. We know at O, t was equal to 0, x was equal to 0, y is equal to 0. At A, t is equal to t, or after certain time it has reached position A, where distance it has covered along x-axis is x, that is v0 cos theta into t, and y is v0 sin theta t minus half gt square. Now at t is equal to 0, v0x was v0 cos theta, and v0 y, or velocity along y direction, was v0 sin theta. Now after certain time t, v0x becomes there is no acceleration along x-axis, hence velocity remains constant. Vx becomes v0x, that is v0 cos theta, and velocity along y-axis after certain time t, where object has reached at position A, is Vy is equal to E0y minus gt. Here velocity changes using the formula v is equal to u plus at. Equal to v0 sin theta minus gt. This is the velocity it has along x-axis, and this is the velocity it has attained along y-axis. Now during its motion, it has reached to its maximum height, which is at B. Here vertical component of the velocity Vy is equal to 0. During the motion, the horizontal component of the motion is v0x, is same everywhere, v0x, v0x, v0x and v0x. This is the fundamental we have to remember. Velocity is constant along x-axis or parallel to ground, velocity changes along y-axis or perpendicular to ground. Another one we require to remember is velocity at maximum height. At maximum height, vertical component of velocity is 0. Then after maximum height is attained, it will have its downward motion and its velocity will be increasing. Hence, during upward motion, where velocity decreases and attains 0 at maximum height, is the velocity along vertical axis, that is Vy. During upward motion, velocity decreases and its corresponding acceleration, which is g, value is g, becomes negative. During downward motion, velocity increases and corresponding acceleration is plus g. This we need to remember that velocity changes along y-axis, and at maximum height velocity of this vertical component is 0. Now we have V0 is the initial velocity at which object, here we say projectile, is thrown. It has its initial velocity along x-axis is v0x and initial velocity along y-axis it is v0y. v0x is the initial velocity component along x-axis, that is v0 cos theta, and v0y is the velocity component of its initial velocity along y-axis, that is v0 sin theta. Now we have two motion. One is our horizontal motion. Here a is equal to 0, that is velocity is equal to constant, that is throughout the motion velocity is v0x, which is equal to v0 cos theta always. During the vertical motion, acceleration is not 0. Here acceleration is either minus g or acceleration is plus g. Minus g for upward motion, plus g for downward motion. Now velocity along vertical direction or y direction is Vy, that changes and its value is its initial velocity v0y minus using the formula v is equal to u plus at, we say v0y minus gt or vy will be v0y plus gt. This is the v0y minus gt for upward motion. Now this velocity along y-axis changes as time changes, and at maximum height Vy is equal to 0. That means at B, where it has attained its maximum height, it has covered a distance, vertical distance h, and attained velocity, that is Vy is equal to 0. Using the formula v square is equal to u square plus 2as. V is the final velocity, use the initial velocity. Here this is Vy square is equal to v0y square minus 2gh, where Vy is 0. Velocity along y component at maximum height or at B is 0. Implies that 0 is equal to v0y square minus 2gh, or h is equal to v0y square by 2g. v0y is the initial velocity along y component, that is v0 sine theta by 2g. This is the height, maximum height it has attained if it is thrown at a velocity v0 and at an angle theta with x-axis velocity. Now we can calculate the maximum height it has attained after certain time t. If it is suppose the max time is t1 to attain maximum height, then we say the maximum height is h max is v0 square sine square theta by 2g. Now using the formula v0, v is equal to u plus at, v is equal to u plus at, to attain this maximum height, let time is t1 and final velocity is v is equal to vy is equal to v0y plus 81, where a is equal to minus g, then Vy becomes v0y minus gt1. Then at maximum height Vy is equal to 0, hence this equation becomes 0 is equal to v0y minus gt1. Now we say at B, Vy is equal to 0. Using the equation V is equal to U plus AT, we find that 0 is equal to V0y minus G T1. T1 is the time taken to move from its start point to maximum height. Then T1 is V0y by G. V0y is the y component or vertical component of the initial velocity, that's V0 sin theta by G. Now, if we consider the complete motion upward and downward, finally, say after time t, it touches the ground, the net displacement along y is equal to 0. During time period t, it has moved the ground and touched the ground, and net displacement along vertical direction is 0, or S is equal to 0, where S is equal to ut plus half at square. Here 0 becomes u 0y t minus half g t square. That means when an object is left the ground, when you consider its vertical motion, after certain time t, what is the displacement? So we find the net displacement is 0 after time t. Using this time t is equal to t, using t is equal to t, we find 0 is equal to v0 yt minus half gt square. Rearranging this, we find out that half gt square is equal to v0 yt. v0 y is v0 sin theta and t. Now it gets cancelled, then t becomes 2 v0 sin theta by g. That is our 2t1. Now, during the motion, it has moved certain distance along x-axis, that we say is the range of this projectile, and this r is equal to velocity along x direction, that is v0x, and time is t. v0x is the component of the velocity along x-axis, that is v0 cos theta, and t is our 2 v0 sin theta by g. Now rearranging this, we find it is v0 square sin 2 theta by g is range. Summarizing, we find out that maximum height it has attained is V0 square sin square theta by 2g. Time period of this projectile motion is 2v0 sin theta by g, and range is v0 square sin 2 theta by g. From this we can find out the H max can have a maximum value when theta is 45 degree, or it becomes V0 square by 2g, where in that case when theta is 45 degree, that is a case of R max, and that value becomes V0 square by g, and the corresponding H becomes V0 square 2g to 1 by 2. That value becomes V0 square by 4g. That means this is the range if an object is thrown with some initial velocity v0 and with a certain angle theta with x-axis. To attain maximum range, this sin 2 theta part becomes 1 and the maximum value becomes v0 square by g. Whereas sin 2 theta is equal to 1, or sin 2 theta is equal to sin 90, or theta is equal to 45 degree. That means if an object is thrown at an angle 45 degree with the x-axis, it will attain its maximum range, and at that time, if theta is equal to 45 degree, it will attain maximum range. To attain this maximum range, the corresponding maximum height is v0 square by 4g. This projectile motion will have oblique projectile motion, which we have studied now. Another one will be horizontal projectile motion. In oblique projectile motion, object is thrown from ground and after certain time it reaches the ground. Wherein horizontal projectile motion, object is thrown from certain height h and it attains certain range along x-axis, and the time it takes to touch the ground is t. Now we need to find out value of r and t. Let the object is thrown with an velocity u. Initially its vertical component will be 0 initially, or at the starting its vertical component will be 0. During the motion, the vertical component, the velocity, will keep on increasing, and the horizontal component, as we know, remains constant. Here again it will have its vertical motion and horizontal motion. Horizontal motion, acceleration is equal to 0, velocity constant. This velocity is nothing but the initial velocity is v. This is the velocity at which the object is thrown. The total and that remains constant during the motion until it touches the ground. During its motion, vertical component of its velocity changes, and acceleration is acceleration due to gravity. Yes, velocity changes and plus g, hence it is increases from 0 to v0 y. Then v0 y this v0 y changes from 0 to its v0 y maximum. This v0 y is the velocity along its vertical component, and it is 0 at beginning, and it becomes v0 y maximum at ground. Now using the formula v square is equal to u square plus 2as, we get vy square v0 y, the v0 y max is the vy, it's called v0 y square plus 2gh is the height of the building or tower from where the object is thrown. This initial velocity along y direction is 0, it becomes 2gh or vy, or velocity with which object will touch the ground. It is p, is vy, velocity at with which object will touch the ground becomes 2gh. Now, using the formula V is equal to u plus 80 is equal to u0 plus 80. As we are considering vertical motion, initial velocity vertical direction is 0, hence V is equal to Vy is 2gh equal to A is our g and t is the time period. Or t is equal to Vy by g or 2gh by g is equal to 2h by g under root. At the time period or time it will take to touch the ground. Now, when you consider horizontal motion, the distance it has moved along x-axis is range is equal to horizontal component of the velocity into t. Here it is, we have taken velocity v0 and t is this is the r. Summarizing all these three equations for this horizontal projectile motion, we find out, now summarizing the complete projectile motion. Under oblique projectile motion, we will have its maximum height, that is v0 square sin square theta by 2g, time period 2v0 sin theta by g, and range v0 square sin 2 theta by g, and the maximum range will be attained. The value will be v0 square by g. This is at theta is equal to 45 degree, and the corresponding maximum height. And when maximum r is attained, we will have certain height, and that value will be v0 square by 4g. Now, under horizontal projectile motion, if the object is thrown from a height h and it has reached the ground with range r and time it takes t, then t will be 2h by g under root, and maximum range is equal to u vt. This v is the velocity at which the object is thrown, and v will the final velocity at which it will touch the ground. It will touch the velocity with which object will touch the ground. And this at initial stage or at the start of the motion, vertical component of the motion is 0. Hence, the velocity at which it is thrown is the complete horizontal motion or complete horizontal velocity. Now, this r becomes v0t or v0xt. v0x is the velocity that remains constant, because the key point here is acceleration is along x-axis 0 along x-axis or parallel to ground, and acceleration is equal to plus g along y-axis or perpendicular to ground. During this oblique projectile motion, key points is velocity along vertical direction Vy is equal to 0 at maximum height, and this Vy changes from its start velocity v0y to 0. Then from 0 to again it attains to v0y, with which it touches the ground. And acceleration is minus g while upward motion, and it is plus g while downward motion. The three key points we need to remember while calculating or solving problems for this oblique projectile. And for horizontal projectile motion, we need to remember these two things. Acceleration along x-axis is always 0, and velocity does not change and velocity remains constant. This is the velocity constant. With this, we have completed the projectile motion. In next class, we will cover uniform circular motion.